Within Delta, our main involvement is threefold. We're involved in the development of the system architecture and the specification of the Delta framework. We're also involved in the development specifically of the aggregator layer and how the components within the Delta architecture will form the role of the aggregator. And we are the pilot site managers for the University of Cyprus. So the new technology will help entities that are significant energy consumers or even prosumers respond in close to real time to events requested by the local electricity grid in order to ease congestion management issues on the grid. So if you imagine that there's a significant amount of solar being generated and then a cloud passes by, and this cloud may reduce the amount of solar significantly for 5 to 10 minutes. But if the demand was matched to the supply and suddenly the supply drops, then we have options. The default reaction for a grid is to just generate more, just turn on another power station. But that is not energy efficient. Your first choice in the future will not be generate more, will be ask people to use less. And obviously that is an inherently more economic and carbon neutral way of reacting to the energy requirements. Currently, there's no real route to market that is economically viable for domestic or tertiary consumers in the system. Not only because the amount of person time and knowledge, expertise, investment is costly. So this entity, this technology, will take away the investments of time and effort and expertise required by those individuals and will operate in an automated fashion. A demand response event would be an event where there is a requirement for people to use less energy. There's a mismatch between supply and demand. Okay. So there may be more demand than supply, and either we need more supply to match the demand, or we need less demand to match the supply. So we need those to be equal. The University of Cyprus campus is a very interesting test case for the Delta project. Not only because it uses a significant amount of energy at a significant expense to the university. The university consumes approximately 12 gigawatt hours of energy annually at a cost of €2.5 million to the university. And because energy in Cyprus is particularly dirty, among the dirtiest in Europe, because it relies significantly on heavy fuels, it's about 10 kilotons of CO2 equivalent output of carbon emissions. So within the University of Cyprus, we have currently 4 buildings in our campus of 17 buildings that are assigned to the Delta pilot site, and this will be expanded into the future. Each one of these buildings has building energy management systems with which the Delta framework will interact and communicate to automatically respond to demand response requests. And the residential use case is a more interesting one because it will involve communicating directly with residential users and installing more specific equipment. We would hope to see the peak output within the pilot sites be reduced by 30 to 40%, which would be a significant finding because it would mean that we could offset the required generation installations for further generation by a similar amount. So if we can reduce peak outputs by 30%, then technically we only need to utilize 70% of the current energy generation at any one point in time. I mean, though they would get to be a part of the energy transition, there would be some small economic benefits. The reality is that it's more of a benefit for the system because in an aggregated sense, domestic users use a significant amount of energy, but any individual user uses an insignificant amount. So for the system as a whole, it would be much more stable if domestic users take part. The world is transitioning from a carbon-heavy energy supply to a clean energy system. And that requires the installation of more renewable technologies that behave in an asynchronous and unpredictable fashion on the network with high variability. So the traditional infrastructure cannot handle that kind of resource in significant amounts. and changes to that infrastructure are required to accommodate clean energy supply. The Delta infrastructure is one of those changes that will help us mitigate some of the negative effects of renewable energies on the grid and allow us to decarbonise our electricity supply.